Hello from Launceston, situated in the north of Lutruwita, Tasmania. My name is Connie Cirkony and I'm a lecturer in science, STEM and sustainability here at the University of Tasmania. I've been asked to answer some great questions about the greenhouse effect, shared by the Year 3 students at Major Mount Stewart School and Margate Primary Thylacines. So hello to the teachers and staff and students at these schools. So in this short video, I'm going to explain the answers to your great questions, show you a demonstration on the greenhouse effect, and provide you with some resources to support your continued learning. Now today we're going to talk about the sun, which generates light and heat energy, and the atmosphere, which is the sky above us, and the earth, otherwise known as home. So in the sky, when we look up in the sky, we can see a lot of natural things such as clouds or rain. Other things we can't see are air and greenhouse gases. So let's pause for a moment and have a think about what gases are, because you probably already learned about what solids and liquids are. For example, let's have a look at this glass of water. So we know that water in a glass can take the form of a liquid, and floating on top is water in the form of a solid. So that's just a glass of ice water. Now, what do you think water would look like if it was a gas? So here's one example of water when it is a gas. So now gases are tricky to understand because we can't easily see them. But let's try this activity. I'm going to take a plastic bag, right? And think about, what is it full of? Well, right now it's not full of much of anything. But if I do this, what do you think it's full of? It's full of air. So air is made up of different kinds of gases. We usually think air is oxygen, and oxygen is in air, but air is mostly made up of nitrogen. So there's at least two kinds of gases in air. So you can also think of balloons. So we can fill balloons with air, but if we fill a balloon with something like helium, when you have a birthday party and you have a helium-filled balloon and it floats upward, well, that just means that the helium in the balloon is actually lighter than air. That's why the helium balloon will float upwards. So some gases are very light and lighter than air, and they can float up into the atmosphere. Okay, this is the review. So what do we know so far? We know that things can be solid, liquids, or gases, and we also know that water looks different when it's a solid, like a piece of ice, versus a liquid, like a glass of water, or a gas. So we also know that air is a gas, and that some gases are even lighter than air and float upwards. All right, with that background, let's talk about the greenhouse effect. So aside from oxygen and nitrogen that make up the air we breathe, other gases in the sky have a very important job as well, and they work together to keep our planet warm. Now, these are the greenhouse gases. And for the purposes of this explanation, there are 6 greenhouse gases, and this is what NASA has provided in terms of the key greenhouse gases. They are water vapor, carbon dioxide, methane, ozone, nitrous oxide, and chlorofluorocarbons. Now, many of these gases are naturally present in the Earth's atmosphere, and actually they were around before humans were. So together, they keep our whole planet at a certain temperature, so it's not too hot or too cold, and in this way, we can survive, we and all other living things. So I guess in a sense, they act like a greenhouse. So you've probably been inside a greenhouse, just like the one in this picture. And how does it feel? Usually it feels warmer on the inside. No matter what the temperature is on the outside, the greenhouse has a particular temperature. And in this picture, you can see that the plants seem to be quite happy in this greenhouse. So how does this work? The greenhouse has the glass around it, enclosing the plants. You think of the greenhouse gases as the glass, and the earth is inside the greenhouse. So light and heat come from our sun and pass through the atmosphere, which is the glass in this greenhouse. Now, some of that heat gets absorbed by the earth. Some of it will reflect off the earth and go back through the atmosphere, back into space. And some of it will reflect off the greenhouse gases, the atmosphere, which is the glass in this greenhouse. And that prevents some of the heat from the sunlight from leaving our atmosphere. It keeps it between the atmosphere and our earth. All right, so let's think about what we know so far. So there are 6 greenhouse gases. Most of the greenhouse gases are natural, and greenhouse gases trap heat from the sun and keep the whole earth at a very comfortable temperature. And this is what's called the greenhouse effect. All right, so what does the greenhouse effect actually look like? Well, remember I said that I was a lecturer at the University of Tasmania? Well, part of my role here is to work with people who are studying to be science teachers. And this year we were actually focusing on the greenhouse effect. So I had 6 of my own students demonstrating how the greenhouse effect works by doing a role play. So let's have a look at what this role play is, and you'll see my 6 students, Alana, Ella, Elizabeth, Lachlan, Michaela, and Nate, demonstrating the greenhouse effect. I'm going to play this video twice. So for the first time, just watch all the activity, and the second time I'm going to break it down. Okay, we're going to watch it again. And this time I want you to notice a few things. First of all, I'm going to introduce Nathan, who is the person standing on the right-hand side. He's wearing a hat. He is representing the earth. Now you'll notice there's 2 people standing around him with their arms out. That's Michaela and Ella. Now they represent greenhouse gases, the greenhouse gases that are surrounding the earth. All right, and then you'll notice there's 3 people who are moving. They're Alana, Elizabeth, and Nate. They seem to be running around. Now they represent warm rays of sunlight coming from the sun, radiating everywhere in space, including the earth. Now some of them are going through the earth's atmosphere. That's where Ella and Michaela are standing. Some reflect off the earth and bounce back into space. You'll see them running back out again. Some of them are reflecting off the atmosphere and back into earth and are trapped. And some are actually absorbed by the earth. You'll see when Nathan and Lachlan come together in a big hug. All right, let's watch it again and watch for those three pieces going on. So this is how you can demonstrate the greenhouse effect. Do you think you can do this as a whole class? You have to think about who's going to be the earth, who are going to be the greenhouse gases, and if you have a lot of people, they can represent different kinds of greenhouse gases, and who are going to be the sun. You're going to need a lot of sunlight and heat energy going in all directions and including sunlight going towards the earth. All right, now let's talk about the enhanced greenhouse effect. So we talked about the greenhouse effect, and actually it's a good thing because it keeps the earth at a comfortable temperature. But what if there's too many greenhouse gases? So the last 200 years, we humans have created more greenhouse gases, especially CO2 and CH4. And when we have more greenhouse gases, it traps more of the heat from the sun, and as a result, the temperature of the earth will increase. So some of the activities that we have been doing for the past 200 years that have increased the greenhouse gases, include the burning of fossil fuels, and that's for industry or transportation, cutting down forests to expand farming or increase land use for other purposes, and of course increasing the garbage going to landfill. So this means more and more heat energy from the sun gets trapped between the Earth and the atmosphere, and the average temperature of the Earth begins to increase. So if you were demonstrating the greenhouse effect, what would you do differently to demonstrate the enhanced greenhouse effect? So what changes would you make to the atmosphere? And what would happen to the sun's heat if there's too many greenhouse gases? So that's my challenge to you, to demonstrate the greenhouse effect and the enhanced greenhouse effect. So here's a summary of the key ideas in the form of the excellent questions that you asked. So please have a read through just to review your understanding. And if you want to know more, please check out these great resources by NASA. The first one is Meeting the Greenhouse Gas. So this is actually a card game, an activity that talks about those 6 greenhouse gases that I mentioned. And then the second link is a demonstration of the greenhouse effect, but through an animation or a simulation. All right, so have a look at those 2 resources, and special thanks again to my pre-service teachers who shared their role play. All right, take care. Bye-bye.